this question in GoLang. So we want to reschedule meetings to achieve maximum free time, which means essentially we want to have like the biggest possible gaps, and we are allowed to move any of those blocks. We're allowed to move it, around within that event time. That's so we can move it in this case between 0 to 5. Okay, and now the way we can do it is so we receive event time, start time, and time. So those are our meetings. Those are those blocks. So what we can do is we can calculate the gaps, keep track of those gaps, including gaps at the beginning and at the end, and gaps in between blocks. And then we can move each of those blocks if there is a space which would fit that particular block. Yeah. So if we have, let's say in this case we don't, but if we had 6 and if event time was 6, then we could put that block here, and in that way we would get that entire space available. So that's kind of like one option which we have to move that block in between other blocks. Yeah, so to throw that block in between other blocks, or possibly if the best answer could be also just moving that block either to the left or to the right without putting that into another gap. So that's sort of something which we want to simulate. Yeah, want to simulate throwing that block in between other blocks, or just moving that to the left or the right. And the way we can do it is by essentially we need to know if there is like enough space on the left or right. So we can achieve that by calculating suffix for biggest gap on the right, and prefix for the biggest gap on the left. And it's calculating sort of like if that movement is if that movement gives us any valid maximum time, it's actually quite easy, because if we move the block to the left or right, it means that we essentially getting that part and that part. Yeah. So if we move that block here, we receive that part as our available free time, and it will be exactly the same if we move to the right. So we don't need to sort of like test both scenarios. Just available time will be for that kind of action will be the sum of gap on the left and right. So that's kind of like, those are two things which we need to simulate. Yeah? Like throwing that block in between other blocks, which we can do if there's enough space between other blocks, and know if there's enough space in an efficient way, we can use suffix and prefix from the left side. Okay, so now how can we actually implement that in GoLang, the language which I'm learning right now? So we can store in an array, or it's called slicing Go. We can store our gaps. So let's say we're gonna have gaps, and can say make gap with integers, and we can initialize them with 0. So that should give us our initial array filled with 0. The length of that array will be actually different. So actually that doesn't fill. That's the length of the array. So the length of the array will be amount of possible gaps. So we're going to have one gap at the end, at the beginning, one gap at the end, and meetings minus one gaps in between, which means altogether we're gonna have n plus one gaps, which is where n is amount of meetings. We can say that n will be start time length of that array, and the amount of gaps will be n plus one. Okay, so now we can actually calculate those gaps. So we're gonna say that we're gonna keep track of our previous n, and then we're gonna iterate through our meetings. So we're gonna say for I equal to 0, I smaller than n, and I plus plus. So our start is our current start, let's call it, is equal to start time at I, and our current end is equal to end time at I. So now the gap in between is equal to gap between our current start and previous end. Let's say that that's our current start. The gap is between current start minus previous end. So now we can say that gaps at I would be equal to current start minus previous end, and we want to keep track of that previous and will be now current and okay. So now we have gaps. Next thing which we need is our suffix. To know if we're able to move the current block to the right. So now I'm gonna say so for the suffix we're also gonna use array. I'll say suffix make array filled with integers, and it will be also n plus 1. Okay, yeah, n plus 1 because yeah, then when I will be at, let's say, at 5, so I'll be at 5, which will be rather I'll be at the second event which is at index 1. So I want to check if at I want to sort of see if at index 1 plus 1, which is 2, if there's what sort of what's the biggest gap to the on the right, and I mean at the end of that would be there'll be no gap, yeah, because like we use suffix to find like the place to put our current block in between other blocks, not to move it to the left or right. Okay, and then again we can use our loop. I smaller than n. Okay, and now again we can say that like the suffix that I will be equal to so actually we want to go from the right, yeah? So we want to go from the n minus 1. Yeah, we want to know what's happening on the right. So now I'm going to say that my suffix So I can say maybe that would be easier. So if if let's say gaps at I+1, so if that like next gap, going from the right to left, so it's sort of like previous gap. If that gap is bigger than if it's bigger than su let's call it suffix at my previous suffix. And so if it's bigger than previous suffix, then I'll be using that that new gap. Yeah. So then suffix at I will be equal to gaps at I+1. Yeah. So that's kind of like tricky to because you need to be careful with those indexes. Like we have here sort of like delay by 1. Yeah. So at that index, I'm keeping track of like what was happening up until this index, but excluding that current index. So what was happening there was that either that that previous gap was bigger, or if it wasn't bigger, I just copy over like the previous biggest, which is stored at suffix at I plus suffix at I+1 suffix at. Okay. Seems to be error. No. Okay. Yeah. So okay, in this way I have my suffix. Now for prefix, I'm gonna just store it in a variable. Say prefix, or I can call it like max left. And that's I will start it as 0. And so for the first event, there's not gonna be like event on the left to throw our current event there, because that's the first event. And now again we can go through our events. So let's say I something at 0, I smaller than n, I plus plus. And now if there was enough space on the left, so if max left, if there was enough space for our current event, which our current event would be, let's say start will be at start time at I, end is at end time at I. And our duration is end minus start. So if there is enough space for that duration or equal, then we can throw that block there, or if there is enough space on the right, we can also do it. So if there's enough space on the right, I'm gonna use again suffix at I gonna say +1. Yeah, it's very easy to make a one of error. So if that's bigger or equal to duration, then we can also throw it there. And then we can, by throwing that, we just need to keep track of the best, the maximum available time. So we can have a variable to keep track of that. Let's go 0. So now if best So if our current best is smaller than yeah, so what we gain if we're throwing our current block in between some in between space around other blocks, we're gaining space on the right, left, and that duration. So if so I think maybe another variable gains space, and that'll be equal to gaps gap on the left, which is under that index plus gaps at I plus one, which is that's the right gap. So plus plus our duration. Okay. So now if best is smaller than gain space, then that becomes our best. Best gain space. Okay. And like another option could be that we just moving our current block to the left or right. So then again, we can have we can have like another say variable, and that variable will be keeping track of. So if we move it to the left or right without throwing that into some other into between some other blocks, then we only gaining space from those two gaps, which could be potentially a solution. So now if our gain space is if that's bigger than best, then that becomes our best. Okay, and essentially that's what we'll be returning. Want to return best. Okay, yeah, let's see if that's working. Okay, we have gaps. We're calculating gaps. We're updating previous n. We have suffix. Okay, that's good. If okay, that passed. Okay, and yeah, let's submit it. Okay, that's wrong. Okay, let's see. Let's see what was wrong there. We have 34. Expected 18. Okay. Yeah. So then the thing is that we have we're missing our last gap. Yeah. So we have gap at the beginning, in between blocks, and at the end. Yeah? And we forgot to add that gap, and that gap will be gaps at n, and that will be equal to event entire time of the event minus previous end. Okay, let's submit it. Okay, it's again wrong, although it passed our previous test. Okay, so it's a small error. Okay, updating that. Okay, if gaps at if our next gap was okay, potentially that's wrong. If our okay, if our sort of next gap is bigger than our it's bigger than suffix. Okay, then we are taking our suffix to gaps at I+1. So let's say our let's say we have event time. Let's say we have event time 6. Let's say we have 6 here. Okay. And our suffix should be equal to for the last suffix. So last suffix will be 0. Suffix has n+1 items, but the suffix at n-1. So that suffix will be equal to the last it will be equal to the last gap. So that gap would be gaps at I+1. Okay, I don't think it's correct actually. Yeah, yes, suffix at 1. Suffix at 1 should be equal to 0. Well, even if there is even if event time is 6, that's why I'm saying here that that's why I'm like using here I+1. Okay, I think I know what's the problem. So yeah, we wanted to keep prefix under that variable, but we don't update it. Yeah, we need to keep updating that prefix. So we need to say that if max left is if current max left is smaller than our biggest gap on the left, yes, which is gaps at I, then we're gonna update max left to be equal gaps at I. Um, okay. Yeah, there's a missing bracket. But I think that should solve the problem, and yeah, it's accepted. Okay, yeah, thank you very much. And yeah, that's it for today. Yeah, thank you.